is A. Similarly, A12 in the first matrix is 1. A21. Find the values of A and B if the two matrices are equal. Now if you look at both the matrices here, A11 of the first element is A. Similarly, A12 in the first matrix is 1. A21 in the first matrix is 2. And A22 of the first matrix is 3. We have identified every element of the first matrix. Now in the second matrix given, what is B11? Yes, it is 7. B12, that is the first row, second column, the number is 1. B21 is 2, right? Second row, first column. And then B, second row, second column, the number is B. Now what is given? The two matrices are equal. Yes, the orders of the two matrices are equal. Then what else is the condition remaining? The elements at the corresponding position must be equal. If you look at this condition and this condition, we can identify that A12 is already equal to B12. And similarly, from this equality, we have A21 equal to B21. Now, when we say the complete matrices are equal, yes, A11 must be equal to B11. Then shall we say A equal to 7? Yes, we have identified the value of A. Now these two elements also must be equal, then only the two matrices would be equal. That means A22 element must be equal to B22, or shall we say the value of B is 3. Yes, we got the value of B also. So what are the suitable values of A and B for which the two matrices are equal? A is 7 and B is 3. Then the two matrices are equal. Now it's very easy to identify which of the following matrix is a triangular matrix. Now if you remember the triangular matrix definition, there are two cases. If a matrix Aij of order m by m, square matrix, is a triangular matrix, what are the two possibilities? If Aij equal to 0 for all I greater than j, then we said the matrix is a upper triangular matrix. Right? Now similarly, if Aij equal to 0 for all I less than j, then we called the matrix as a lower triangular matrix. Now we wanted to identify both the cases, either an upper triangular or lower triangular. Let's observe the first case A. In the matrix A, if you look at in the first choice, yes, A11 element is 1. Similarly, A12 element is 0. Yes, satisfied. But A13 element is non-zero, but A23 element is 0, right? So in order to have an upper triangular matrix, all these entries here must be 0, but there is an exception here. So does A being a lower triangular matrix? No. Now look at second choice. Is there any, according to the principal diagonal? Yes, all the elements to the left of principal diagonal are zeros, right? All these elements are zeros. So what kind of a matrix is B? In B, every Aij is 0 whenever I is greater than j. Therefore, shall we say the option B is a upper triangular matrix. Now similarly, let us observe a C case also. In C, the principal diagonal is 1, 2, 7, and if you can observe, the elements to the left of the principal diagonal are all zeros. Therefore, even in the option C also, Aij became 0 whenever I is greater than G. So the matrix given at choice C is a upper triangular matrix, right? So what are the upper triangular matrices? Triangular matrices as per the requirement? Yes, the options presented B and C, both are triangular matrices. So which is a suitable option for this? Option B and option C both will satisfy a triangular matrix. Now here again, equality of matrices considered. When the two matrices are equal, we need to find the values of A and B. Let's identify the elements. A11 of the first matrix is AB. A12 of the first matrix is 1. Similarly, A21, that is second row, first column of the matrix, is C. And A22 element of the first matrix is A by B. Now we have identified different elements of the first matrix. What is second matrix, first row, first element? Yes, that is given to be 8. What is second matrix, first row, second column entry? That is 1. What is second matrix, second row, first column entry? That is 2, right? And second matrix, second row, second column, that is B22 is 2. Now when do we say these two matrices are equal? Provided these two entries are equal. That means A into B must be equal to 8. Let's call it as an equation 1. Now these two are already equal. But for the matrices to be equal, even these two entries must be same. That means C must be equal to 2. This is our second equation. And also these two elements A22 and B22 must be same. That means A by B must be equal to 2. Let us call this as an equation 3. We need the values of A and B. Now if you look at equation 1 and 3, there are two simultaneous equations in A and B. So when we consider the equations 1 and 3, can we replace A into B equal to 8? Then from second equation we can replace A with 2B. Then this becomes 2B into B equal to 8. Or shall we write B square equal to 4? Or B as plus or minus 2. When B is plus or minus 2, how will be the value of A? Yes, A would be 2 times plus or minus 2, or that is plus or minus 4. So what are the possible values of A and B? A and B should be either 4 and 2 or minus 4 and minus 2. Then only the product of A into B will become a positive number 8. Similarly, A by B will become a positive number 2. That's why we took either both of them positive or both of them negative. So how many possible values of A and B are there? A and B are having two different possibilities, 4, 2 and minus 4, minus 2, right? Which of the following represents a diagonal matrix minus 1, 1, 4? Yes, as we know, the diagonal of minus 1, 1, 4 should be a matrix of 3 by 3 order, because diagonal has 3 elements. That means it should be a square matrix of order 3 by 3. In this 3 by 3 matrix, the principal diagonal elements must be minus 1, 1, 4, and all the rest of the elements must be 0. That means the entry at A21, the entry at A12 should be 0, the entry at A13 should be 0, the entry at A21, A23, A31, A32. These all entries must be 0. So let us check which option does it satisfy. The matrix given its choice C is same as that of minus 1, 0, 0, 0, 1, 0, 0, 0, 4. Then the diagonal matrix minus 1, 1, 4 is denoted by option C, right? Now clearly A is not a diagonal matrix at all. B is also not a diagonal matrix. But D is a diagonal matrix. But what is the difference? Yes, this denotes, actually this will be denoted as diagonal 4, 1 and minus 1, right? But what we want is diagonal minus 1, 1, 4. That's why option C was the suitable choice. Now, which of the following statements are correct? Let's identify the correct statement. Every diagonal matrix is a scalar matrix. When we consider a diagonal matrix, say minus 1, 1, 4, then how will be the matrix of this? Yes, it would be minus 1, 0, 0, 0, 1, 0, 0, 0 and 4, but this is not a scalar matrix. In a scalar matrix, the principal diagonal elements must be all equal. So every diagonal matrix need not be a scalar matrix. So shall we conclude A is false, need not be always true. Now every scalar matrix is a diagonal matrix. Yes, obviously by definition every scalar matrix is a diagonal matrix. Now if A is m by n matrix and B is 2 by 1 matrix, then and the both are equal. Yes, the first condition of equality of matrices says m by n must be equal to 2 by 1. That means the number of rows must be equal, m equal to 2, and the number of columns must be equal, n equal to 1. Therefore, the statement C is also a true statement. Identity matrix has all principal diagonal elements equal to 1, right? Yes, by definition this is also true. So what are the true statements? Option B is true, option C is true, and option D is also true. The only false statement is at option A. Now here we need to identify the incorrect statement. Let us see first one. A row matrix has only one row. Yes, this is true by the definition of a row matrix. Every identity matrix is a square matrix, correct? This is also true by the definition itself. Now, all entries 1. Is this a unit matrix? If you remember the unit matrix, say I, and as example has a 3 by 3 entries, let us say I 3 by 3, then how should be the identity matrix? Yes, it should be 1 0 0 0 1 0 0 0 1. A scalar matrix having all the principal diagonal elements 1 is a unit matrix. But if you look at here, all the entries are 1. So what do we conclude? Option C is false, right? Now let us see what is the next option says. Is this a triangular matrix? Yes, because if you look at the entries which are to the right side of the principal diagonal, that means these entries are all to the right side of the principal diagonal, all elements are 0. So in fact this is a lower triangular matrix, isn't it? By definition, Aij became 0 whenever I is less than j, right? Then such a matrix is called a triangular matrix. So even the choice given at D is also a true statement. So what is the correct option for this question? Yes, option C is a incorrect statement, that the given matrix is not a unit matrix. Now here a matrix is given e power x 0 0 0 sin y 0 0 0 and z plus 1. And is given to be an identity matrix. Now when do we say this is an identity matrix? If the matrix given, that is e to the power of x 0 0 0 sin y 0 0 0 and z plus 1. This matrix must be an identity matrix. So how does a identity matrix of 3 by 3 look like? Yes, it will be in the form 1 0 0 0 1 0 0 0 and 0. If you look at all the remaining elements are equal, let's compare the principal diagonal elements. E to the power of x must be 1, or from here can we conclude x value is 0? Yes, the first element x value obtained. Now when you compare the second row, second column entry, that is sin y must be equal to 1, or this is true if y is pi by 2, right? We have identified the value of y also. Then one more entry is remaining. Yes, the third row, third column entry. When do we say z plus 1 element should be equal to 1? Provided the value of z is 0. Now we have x value, y value and z value. What is the requirement? We want the value of cosine of x plus y plus z. Now let us replace those values. Cos of x is 0, y is pi by 2 and z is 0. So what we left with is cos pi by 2. How much is cos pi by 2 value? Yes, the value is 0, which is present at option B, right? So thank you with the session. In the coming session, we'll learn some more extensions of properties of matrices, and we'll also learn about a very important character